Alright, so macam mana nak buat alkene? So that's why you need to learn about the preparation of alkenes. Okay, you boleh buat alkenes melalui type of chemical reactions, elimination reactions. Ingat lagi tak? We have learned about the type of chemical reactions ni dekat 4.1 di mana ada 4 of them, and one of it ialah elimination reaction. Elimination reactions ni di mana daripada single bond dapat double bond, because why? Because kita eliminate dua benda. Okay, eliminate dua benda. So basically bila nak buat alkene ni ada dua cara. Yang pertama ialah melalui cara dehydration of alcohols, di mana if you ada organic compound of alcohols yang nak tukarkan dia kepada alkene, you kena eliminate dua benda, di mana you need to eliminate H dan juga OH. Okay, supaya you dapat carbon-carbon double bond. Okay, sebabkan you eliminate H dengan OH tu, that's why lah dehydration of alcohol ni, D ni maksudnya buang hydra ni H2O. Okay, so dehydration of alcohols, buang H2O daripada alkohol. Next ialah dengan cara you dehydrohalogenation of alkyl halide. If let's say, okay, alkyl halide ni dikenali sebagai haloalkane juga. If let's say you jumpa organic compound haloalkane. Haloalkane apa? Alkane yang ada halogen sebagai substituents, itulah haloalkane. So basically kalau haloalkane you kalau let's say you nak form alkene, okay, you need to eliminate dua benda juga. Apa dua benda yang di-eliminate tu? Dia akan eliminate hydrogen dan juga halogen from the haloalkane. Sebab itulah nama proses dia ialah dehydro. D tu maksudnya pembuangan, okay. Hydro, hydrogen, halogen lah. Dehydrohalogenation of alkyl halide. Ini akan buang hydrogen dan halogen from haloalkane. So daripada single bond dapatlah double bond, dapatlah alkene. Okay, so let's go through the first type untuk you prepare alkene melalui cara dehydration of alcohol, di mana kalau let's say you ada alcohol, okay, and then you need to reactkan dia dengan strong acid catalyst in the presence of heat, okay, nanti you akan dapatlah produk alkene dan juga water, di mana kat sini the type of reaction yang terlibat ialah elimination reaction, okay, di mana kita eliminate dua benda kat sini, di mana kita akan eliminate hydrogen dan juga OH, okay, kita akan eliminate OH dekat another carbon atoms, okay. So that's why daripada kita eliminate dua benda ni, dia jadilah double bond, and also since we eliminate H dengan OH adalah set product water. And dehydration of alcohols ni actually dia follow Saytzeff's rule. What is Saytzeff's rule? Nanti I akan terangkan to you later on, okay. So acid catalyst yang digunakan famously adalah concentrated sulfuric acid, ataupun you can use concentrated phosphoric acid. Asalkan your acid catalyst tu dia kena ada perkataan concentrated, okay. Tapi acid catalyst tu you can use either H2SO4 ataupun H3PO4. And you need to remember bila nak write down the chemical reactions ni, okay, reagent kena ke atas. Alright. Reagent you have to letak dekat atas arrow. Reagent atas arrow. Condition, ni condition dia heat followed by heat kan. Okay, condition kena letak dekat bawah arrow. Okay. You can see here, for example, this is the dehydration of alcohol jenis ethanol. Ethanol ni et, maksudnya ada dua carbon atoms. And then dekat carbon atom yang cumanya kat sini, bila daripada ethanol you nak tukar jadi ethane, you have to undergo elimination reaction lah, di mana kita akan gunakan reagent concentrated acid H2SO4. Kena ada perkataan concentrated ni, and with the condition heat, therefore kita akan eliminate this hydrogen atoms dekat this carbon, and also this OH dekat this carbon atom. So jadilah dia ethane, and also dapatlah zat produk H2O. Okay, formation of alkene yang di mana di bawah dehydration of alcohols ni must follow the Saytzeff's rule. Okay, previously we have talked about Saytzeff's rule. So what is Saytzeff's rule? So basically Saytzeff's rule ni dia adalah rule di mana bila you buat dehydration of alcohol, you kena form the most stable alkene as the major product. Apa tu most stable alkene? Most stable alkene ni bila carbon-carbon double bond tu dia banyak alkyl group yang attached to it. Okay? Dia adalah the most highly substituted alkenes. For example, as you can see here, the stability of alkene increase bila kita letak lagi banyak alkyl group yang mengelilingi this carbon-carbon double bond. So, it will make this carbon-carbon double bond the highly substituted alkenes. Okay? Alkyl group ni, dia tak kisahlah CH3 ke, CH2, CH3. In this example, kita gunakan CH3 sebagai contoh alkyl group. Okay, tapi if let's say in future, if let's say you ada dapat form alkene carbon-carbon double bond daripada dehydration of alcohol, if let's say dia ada dua possibilities of untuk buat dua jenis alkene, you have to make sure the major product tu must be the one yang carbon-carbon double bond tu ada banyak carbon atoms yang attached pada carbon-carbon double bond tersebut. Kerana itu adalah the most stable alkene. Faham tak? Okay, for example, if you look at this butane 2O, okay, kalau dia nak buat dehydration of alcohol, dia akan eliminate dua benda kan. Okay, so dia akan eliminate H dan juga OH. But if you look at this butane 2O, okay, dia ada possibilities untuk form dua jenis alkene yang berbeza, which is this alkene ataupun this alkene. Kenapa? Okay, kan kita dah bincang yang dehydration of alcohol tu kita akan buang OH dan juga H dekat carbon yang neighbor. Carbon neighbor, you tengok carbon neighbor dia ada this carbon and this carbon, right? So first thing first, kita akan remove this OH. Okay, dia akan form dua possible alkenes sebab if I remove H from here, I will form this alkene. If I remove H dekat sini, I akan form this kind of alkene. That's why lah ada dua jenis alkene yang berbeza. Cumanya untuk tentukan mana satu yang major product, kena tengok dekat carbon-carbon double bond tersebut. Okay, which carbon-carbon double bond yang adalah highly substituted alkene. So we have to check it out lah. Okay, contohnya kalau let's say I remove hydrogen dekat sini, okay, if I remove this hydrogen, I akan buat double bond dekat sini. I akan dapat double bond dekat this carbon-carbon, carbon ni dengan carbon ni, because I dah remove OH dengan H from here. Therefore, I will form this kind of product. Okay, di mana carbon belah kiri ni ada alkyl group, okay, ada alkyl group CH3 and also this carbon double bond pun ada alkyl group CH3. So dia ada dua alkyl group around the carbon-carbon double bond. Okay, around here, carbon-carbon double bond. Next, if let's say I remove, this hydrogen atom pula, how? Okay, for example, kalau let's say I remove pula this hydrogen atom, what will happen? I akan buat double bond dekat sini. I akan dapat double bond dekat sini. So, bila I dapat double bond dekat sini, if I look at this carbon-carbon double bond, okay, kalau tengok carbon double bond belah kiri ni ada dua hydrogen atoms. So, this is not alkyl groups. Kalau tengok dekat carbon belah kanan pula, dia melekat dengan satu hydrogen atom, lepas tu satu lagi alkyl, CH2, CH3. Okay, so dia hanya ada satu kali alkyl group. CH2, CH3 is alkyl group ethyl. Okay, so kat sini ada dua alkyl group, sini ada satu alkyl group. Obviously this one is the most stable alkene. So this one will be the major product. Okay, so you need to remember that lah. bila you nak buat dehydration of alcohol, you need to make sure kalau dia ada dua possible alkenes yang dia boleh buat, you need to make sure yang the major product ni will be the most stable alkene. How do you know that it is the most stable alkene? Dia adalah carbon double bond yang dikelilingi dengan banyak alkyl group ataupun it is the most highly substituted alkenes. Okay, so remember lah Saytzeff's rule ni ya. Okay, so ada dua cara nak prepare alkenes. Yang pertama, dehydration of alcohols, which we are currently learning right now. Yang kedua ialah dehydrohalogenation of haloalkane. But mechanism in preparation of alkenes yang you kena study is only about mechanism in dehydration of alcohols. Okay, so you kena remember dehydration of alcohols ni you have to follow the Saytzeff's rule. Saytzeff rule ni cakap apa? Yang most stable alkene adalah yang highly substituted alkene and it has to be the major product. And then kalau let's say previously kita dah belajar pasal Saytzeff's rule, ada dua possibility untuk dia buat dua jenis alkene. So kalau let's say dia soalan suruh buat mechanism for the dehydration of alcohol, you have to follow the Saytzeff's rule and choose the one yang akan dapat major product tu lah yang you boleh buat mechanism. Okay, so let's look at this example. Kalau let's say you ada alcohol, you reactkan dengan concentrated acid catalyst such as H2SO4 ataupun H3PO4 with the conditioned heat, then you will get alkene because you akan remove dua benda which is hydrogen and also OH, and you will get side product H2O. Okay, so macam mana dia punya reaction mechanism is something like this. Okay, this is just the overall reaction mechanism for dehydration of alcohols, tapi we will go through one by one about this later. Okay, so basically apa yang berlaku kat sini, this is your reactant, this is the reagent. You might be wondering, okay, kenapa ada reagent boleh buat plus sign kat sini, ada yang letak kat atas ni. Okay, so sebenarnya kalau let's say dia dehydration of alcohol saja ataupun satu saja jenis reaction, you have to put the reagent tu plus and then reagent kat sini. Okay, kalau let's say ada banyak sangat jenis reaction, baru you boleh letak the reagent tu dekat atas arrow. Tapi regardless, dekat bawah adalah tempat you letak condition heat kat sini. Tapi bila buat reaction mechanism, tak adalah pula ada condition tu yang you boleh letak. Okay, tapi bila buat reaction mechanism, okay, yang first step ni dia akan melibatkan reactant. Reactant kat sini ialah alcohol and also reagent. Okay, reagent kat sini yang digunakan ialah concentrated H2SO4, tapi tak perlulah letak concentrated bila nak buat reaction mechanism ni. Cuma ni H2SO4 ni kita akan jarakkan dia jadi HOSO3H. So you need to remember bila buat reaction mechanism, kalau dekat oksigen tu, okay, oksigen kena tulis lone pair. Okay, lepas tu since that this is alkene, kita tak buat homolytic cleavage. Okay, homolytic cleavage hanya pada alkene sahaja. The next reaction mechanism yang you akan belajar selain daripada alkene, everything is heterolytic cleavage. So bila heterolytic cleavage, you kena remember you need to use a double-headed arrow, and also dia punya product that you will get ialah cation dan juga sama ada bukan cation lah, sama ada itulah cation dan juga anion negatif. Okay, itulah apa yang berlaku bila you buat homolytic heterolytic cleavage. Okay, so if you look here, this alcohol, apa yang berlaku kat sini, the first step ialah the oxygen of the OH ni alcohol ni kan, lone pair dia ni akan attack the hydrogen atom of the H2SO4. Lepas tu, okay, as usual, as I told you, kalau you nak buat homolytic ke heterolytic cleavage ke, dekat the beginning of the arrow, it always has to come from the source of electron. In this case, source of electron of this arrow, it comes from the lone pair of oxygen dekat alcohol ni. Okay, lepas tu dia nak ambil this hydrogen. So bila dia nak ambil this hydrogen dekat H2SO4, this hydrogen dia kena break the bond dengan oxygen ni of the H2SO4. So nak break the bond, again the beginning of the arrow has to be from the source of the electron. In this case, the source of electron ada dekat this bond. Okay, ada berapa elektron? Ada dua kan? And then dia pergi kepada this oxygen sebab dia nak buat heterolytic cleavage kat sini. Therefore, bila H dengan O ni dia break up, okay, oxygen ni dia attack H ni sebab dia nak ambil hydrogen ni. So that's why you ada new bond. Okay, you can see here ada new bond kat sini. Alright? Okay, so oksigen ni dia boleh ada dua lone pair dengan dua bonding pair. Tapi kat sini, since that dia ada tiga bonding pair, and also since that dia attack this hydrogen atom, therefore dia akan dapat jadi cation. How about this oxygen? Dia jadi anion. Okay, sebab dia receive dua electron from this bond. Okay, so since that dia receive dua electron from this bond, therefore dia jadilah anion. Okay, itulah dia. Kalau you buat heterolytic cleavage, mesti you kena ingat, mesti ada dia punya reaction intermediate ataupun produk dia tu sama ada satu tu jadi cation, satu lagi jadi anion. Okay, lepas tu this is what we call as, okay, this whole thing yang O plus H2 ni, H2O plus ni, we call it as protonated alcohol. Okay, kenapa kita panggil dia protonated alcohol? Sebab alkohol tu supposedly OH, tapi bila dia buat lagi satu dengan H, dia jadilah protonated alcohol. Okay, sebab dia ada tambah additional hydrogen. Hydrogen kan proton. Okay, so next, the second step is, what happen ialah kita nak form carbocation. Therefore, this arrow ni, beginning of this arrow ni, kita akan buat heterolytic cleavage between carbon dengan protonated alcohol. Kita nak pisahkan bond ni. So bila kita nak pisahkan bond ni, so we have to make a full headed arrow ni daripada this bond kepada oxygen yang ada plus sign ni. Okay, and then therefore apa yang you dapat ialah you akan remove H2O kat sini. Lepas tu carbon ni dia jadi carbocation. Okay, dia dapat positive charge here sebab dia transfer dua elektron kepada this oxygen untuk pisahkan this bond. Okay, so once ni dah jadi carbocation, okay, apa yang berlaku, the next step is you need to ambil anion OSO3H ni. Okay, and then you have to keluarkan the lone pair here. Okay, sebab bila you nak buat heterolytic cleavage ni, nak buat arrow, you have to show dia dapat source of electron tu from where. So kalau let's say daripada oxygen nak attack hydrogen ni, okay, you have to show this arrow ni, dia punya source of electron dia, it comes from this lone pair of this oxygen atom. Okay, so kat sini lone pair of O negative SO3H ni, lone pair dia akan ambil this hydrogen. So bila dia nak ambil this hydrogen, okay, sebab this is acid catalyst, so you need to remember acid catalyst, walaupun apa yang berlaku at the end of the day, it will not be used up in the reaction. So memanglah awal-awal tu kita ambil hydrogen tu, tapi at the end kita kena show yang you akan dapat form juga, form balik dia punya acid catalyst tersebut, H2SO4. So what you need to do, the second last step is untuk form balik H2SO4, this lone pair of this oxygen akan ambil this hydrogen atom, And how about this bond? Dia akan break the bond, tapi sementara dia nak break the bond tu, dia akan terus buat lone pair, but dia akan buat double bond kat sini. Okay, dia akan buat double bond, dia akan attack this bond untuk buat double bond. So lastly, you can see here this H2SO4 yang pada awal ni dekat second step ni dia jadi anion, dia dah jadi balik acid catalyst H2SO4 sebab dia dah ambil hydrogen from here. Lepas tu this bond of hydrogen dengan carbon ni dia terus buat formation of double bond. Okay, so to know more about this, I will explain more details about this reaction mechanism later. Okay, so previously we have looked at the overview for the reaction mechanism dehydration of alcohols, yang di mana alkohol tu hanya akan form satu sahaja alkene. Okay, satu jenis alkene saja yang dia boleh form sebagai major product. Okay, yang this one pula is an overview for the reaction mechanism dehydration of alcohols, yang di mana alkohol tu dia boleh form another two possible alkene sebagai products. Okay, as we can see here, kalau let's say the alcohol dia ada possibilities untuk form major and minor products, okay, you have to follow Saytzeff's rule. Okay, Saytzeff rule cakap apa? Saytzeff rule dia bagi tahu yang in order daripada you buat dehydration of alcohol untuk jadi alkene, you have to make sure the major product must be the most stable alkene. Okay, most stable alkene tu adalah alkene yang highly substituted. Okay, alkene yang ada banyak alkyl groups around it, or alkyl groups around the carbon-carbon double bond. Okay, so for example, if you look at this alcohol, dia ada two possible alkene sebagai produk dia. Okay, and dia akan choose the major product, the one yang the highly substituted alkene, di mana carbon-carbon double bond tu akan dapat banyak alkyl groups. Okay, as you can see here, this is the overview for the reaction mechanism. Okay, and apa yang berlaku kat sini, dia ada buat dua benda tau yang membuatkan dia dapat major dengan minor product ni. Okay, ada dua benda yang dia buat kat sini besides buat elimination. Okay, besides buat elimination di mana dia akan eliminate H and also OH. Tetapi because dia nak maximizekan the carbon-carbon double bond ni supaya dapat banyak alkyl groups around the carbon-carbon double bond, dia buat lagi satu type of reaction di mana dia akan buat rearrangement reaction. Okay, rearrangement ni ada dua jenis saja yang you have to learn, sama ada dia buat 1,2 hydride shift ataupun 1,2 methyl shift. We will go through about this later. Okay, tapi I would like to tengok overview ni for this reaction mechanism dehydration of alcohols yang melibatkan this kind of alcohol. Macam previously you look at the overview for the reaction mechanism, dia gunakan concentrated H2SO4. But what if dia gunakan concentrated H3PO4? As what I told you, you kena pisahkan, buat HO, lepas tu dapatlah PO3H2. Okay, kalau gunakan H2SO4, you pun kena buat HO, lepas tu kan daripada H2SO4, you pisahkan HO, lepas tu SO3. Okay, kalau let's say H3PO4, HO, PO3H2. Okay, you need to remember that. Because why? Because bila you nak buat elimination of H2O ni kan, yang pada asalnya reaction mechanism ni, okay, as you can see here, major product ni terhasil disebabkan oleh dia buat 1,2 hydride shift, di mana nanti kita akan nampak yang double bond ni dia macam mana, yang dekat bila dia nak form the acid catalyst tu, dia akan ambil hydrogen yang bila dia dah buat 1,2 hydride shift tu lah. Okay, macam ni. Kalau let's say if you tengok alkohol tu, dia ada chance untuk buat dua possible alkene sebagai produk. Okay, the only reaction mechanism yang you need to do, kalau question tak mention, if the question doesn't mention nak major ke minor, you have to do the reaction mechanism only for the major product sahaja ya. Okay, so kalau you tengokkan, kalau ikutkan, okay, mula-mula dia buat elimination of this OH. Okay, di mana this OH will be will be eliminated. Okay, cumanya you nampak tak kat sini dia buat carbon-carbon double bond dekat this one. Sebab kenapa? Sebab dia buat 1,2 hydride shift. Kiranya dia ada buat rearrangement reaction kat situ supaya dia nak maximizekan supaya carbon-carbon double bond ni dapat banyak alkyl groups around it. Okay, memanglah OH dia ambil from here. Tetapi suppose kan kalau kita ikutkan you have to take hydrogen from the neighbor, which is this hydrogen lah kan. Okay, tapi if you take hydrogen from this neighbor, you akan dapat minor product. Okay, tapi dia ada chance untuk that carbon-carbon double bond supaya dia dapat jadi more stable alkene, supaya dia dapat maximizekan alkyl groups around the carbon-carbon double bond. Therefore, bila buat rearrangement, kita ambil hydrogen kat sini. Okay, so bila ambil hydrogen kat sini, makanya carbon-carbon double bond akan terbentuk kat situ. Therefore, teruslah dapat major product. Okay, cuma OH memang kita ambil from here. Tapi bila nak dapatkan major product, the most stable alkene ni, kita akan ambil H from here. Kita akan buat 1,2 hydride shift. Kita akan buat rearrangement reaction. Okay, kat sini step dia sama je, lebih kurang macam previously, di mana kita akan protonate the alcohol, where the oxygen of this alcohol ni, OH ni, the oxygen ni lone pair dia akan ambil hydrogen from the acid catalyst. Lepas tu this hydrogen dia akan break down dengan the rest of dia punya acid catalyst lah. Okay, so dia akan buat heterolytic cleavage. So bila buat heterolytic cleavage akan terhasil lah cation dengan anion, di mana cation kat sini is the one yang attack the H. Okay, so O dapat jadi O+. Okay, because dia attack H ni, dia ambil H. Okay, so dia ambil H, makanya dia akan buat new bond dengan hydrogen from this acid catalyst. And this acid catalyst now dia dah lose the hydrogen, therefore dia akan dapat jadi an ion. Okay, dia rules dia macam tu. Kalau you buat heterolytic cleavage, memang kita akan belah bond kat sini, kita akan break the bond. Yang ni dia akan ambil, ni dia akan break. Okay, tapi reaction intermediates yang akan di-form, yang akan dihasilkan ialah cation dengan anion. You have to make sure of that. Okay. Lepas tu, apa yang berlaku kat sini, as usual, previously we have looked at this protonated alcohol. Okay, dia akan break the bond dengan the rest of this hydrocarbon. Okay, di mana kita akan break the bond between this carbon and this protonated alcohol. So, nak break the bond, daripada bond ni, you have to show arrow menuju kepada H2O plus ni. Tapi bila dia dah break the bond, dia jadi H2O biasalah, di mana kita akan eliminate the H2O. What happen here, bila kita break the bond kat sini, okay, carbon ni dia akan jadi carbocation. Okay, carbon ni akan jadi carbocation. Tapi, okay, previously the next step should be kita akan ambil hydrogen untuk menghasilkan kembali acid catalyst H3PO4 kan. Tapi because kita nampak ada peluang cerah untuk carbon-carbon double bond ni supaya dia dapat jadi major product, supaya dia dapat banyak alkyl groups around it. Therefore, what we gonna do is we are going to do 1,2 hydride shift. Okay, di mana kita shiftkan kedudukan hydrogen dan carbocation. Kat sini, we will shift kedudukan hydrogen and carbocation. Sekejap ya, I'm going to highlight this one, hydrogen and carbocation. This plus sign. Kita tukar kedudukan dua ni sahaja. Okay, bila tukar kedudukan dua ni, therefore carbocation ni akan berpindah, the plus sign ni akan berpindah kat sini. the hydrogen akan berpindah dekat this carbon. Faham tak? Itulah nama dia 1,2 hydride shift. Bila kita swap, okay, bila kita swap kedudukan cation plus sign and hydrogen dekat the neighbor. Okay? Dia boleh buat 1,2 hydride shift, dia tak boleh buat 1,3. You tak belajar tu kita buat 1,2 hydride shift ataupun 1,2 methyl shift. Ikutlah, kalau sini methyl jadi methyl, jadi 1,2 methyl shift. Kalau hydrogen jadi 1,2 hydride shift. And therefore, as you can see here, this carbon atom kat tengah-tengah ni dapatlah jadi carbocation ion, ada positive sign. And then sekarang ni barulah kita dapat the major product and the most stable alkene. Apa yang berlaku kat sini, kita akan form kembali the acid catalyst H3PO4 because acid catalyst ni is not being used in the reaction. Okay, so that's why kita kena form kembali. Macam mana nak form kembali acid catalyst ni? Okay, the lone pair of this anion oxygen PO3H2 ni, okay, dia punya lone pair akan attack this hydrogen. Kenapa dia ambil this hydrogen? Because kalau dia ambil this hydrogen, nanti this bond ni naik atas jadi double bond, kita akan dapatlah major product. Kalau ambil this hydrogen, apa yang berlaku? Kita tak akan dapat major product. It will fall back to be the minor product, which in this case, kita nak buat reaction mechanism walaupun dia ada major dengan minor. Okay, tapi kalau soalan tak tanya, basically normally memang dia akan nak suruh kamu show reaction mechanism of the major product. Okay, so you have to make sure this lone pair kena ambil this hydrogen, not this hydrogen. Kalau this hydrogen, nanti dia naik atas, dia akan form minor product. Faham tak? So that's why dia kena ambil this hydrogen. Lepas tu nanti bond hydrogen ni dengan carbon ni dia naik atas untuk form double bond. So therefore you will get lah the major product. So this is how you do reaction mechanism dehydration of alcohols yang melibatkan major dengan minor product. Okay, dan melibatkan rearrangement. Okay, so previously I already explained to you guys about the overview for reaction mechanism dehydration of alcohols, and I bet that you must not understand it in just one go sebab itu adalah overall. Memang kalau let's say you dah terror, dah power, you boleh terus buat all of that in one go. But right now I want to teach you the step by step for the reaction mechanism dehydration of alcohols. Okay, so for example, kalau let's say you ada alcohol and then you nak buat alkene, you have to gunakan reagent acid catalyst concentrate H2SO4 ataupun H3PO4 with the condition heat. In this case, kita tengok this example, dia daripada butane to all. Okay, as you can see here, dia ada dua possible alkene sebagai produk, dan di mana major product ni dia akan follow Saytzeff's rule. Okay, Saytzeff's rule cakap apa? Saytzeff's rule say that the major product should be the most stable alkene. Okay, di mana the most stable alkene tu ialah the highly substituted alkene, which the carbon-carbon double bond tu dia akan ada banyak alkyl groups around it. Alright, so as usual, bila kita nak buat dehydration of alcohol, the type of reaction yang terlibat adalah elimination reaction. Okay, so bila elimination reaction ni, that means we have to eliminate dua benda. In this case, daripada alcohol nak form, kita nak buat alkene, therefore we need to eliminate OH and also H from the neighbor carbon. Okay, so if you look at this butane to all, okay, I don't think dia ada buat rearrangement reaction pun, just because of as you can see here, dia hanya ada dua pilihan hydrogen kat sini, sama ada hydrogen belah kanan atau belah kiri. Okay, unless kalau this OH ni dekat hujung sekali, so probably dia ada chance untuk buat rearrangement reaction. So I think the type of chemical reaction yang terlibat kat sini hanyalah elimination reaction. Cumanya dia boleh form major dengan minor product is because dia ada dua pilihan kat sini, sama ada nak ambil hydrogen from this one ataupun ambil this hydrogen. Okay, memanglah OH kita ambil from here, Tapi H ni dia ada dua possible H yang dia boleh pilih untuk form dua possible alkene, sama ada hidrogen belah kanan atau belah kiri. Okay, kalau let's say ambil hidrogen belah kanan, okay, makanya terhasillah double bond dekat sini. So bila terhasil double bond dekat sini, therefore this will be the major product, since that this will be the most stable alkene. Okay, sebab dekat around this carbon-carbon double bond, kita tahu ada dua alkyl group around it, which is this one and also CH3 yang this one. Okay, tapi kalau minor product, if let's say I ambil hydrogen from this, from dekat carbon belah kiri ni. So if I discard, eliminate the hydrogen from this carbon, therefore I will form double bond around here. Okay, so bila I form double bond around here, as you can see here, kalau I removekan dua benda ni, I hanya akan dapat satu saja alkyl group, which is dekat belah sini sahaja. Yang ni kan dua hydrogen, so itulah dapat alkyl group yang dekat ni, ethyl sahaja. Therefore, this will be the minor product. Tapi bila when it comes to reaction mechanism, although that you dapat dua possible alkenes sebagai product, okay, bila when it comes to reaction mechanism, if the question doesn't ask you to do the reaction mechanism on the minor product, therefore memang sah-sah disuruh kamu buat reaction mechanism on the major product. Okay, so always do reaction mechanism for major product if ada minor product. Kalau soalan tanyalah pasal soalan reaction mechanism ni ya. Okay, basically the reaction mechanism of dehydration of alcohol, dia melibatkan 3 steps. Okay, so the first step is protonation of alcohol, the second step is the formation of carbocation ion, and the last step, step 3, is the formation of alkene, which is a major product. Alright, so previously what I have showed you is the overview. So kalau let's say you dah pro nanti, you bolehlah buat overview tu terus, okay? Macam bila gabungkan dia jadi panjang macam tu, okay? Kalau let's say you nak buat step by steps pun tak ada masalah, lagi selamat. And then you boleh check everything here, okay? So the first step for the reaction mechanism dehydration of alcohol ialah protonation of alcohol. Okay, protonation of alcohol ni macam mana? Okay, kita tahu alkohol dia punya functional group dia ialah OH. Kalau protonation, maksudnya OH ni dia akan receive satu proton ataupun satu hydrogen. And where will we get this proton from? We can get this proton daripada acid catalyst. Okay, so for the first step, okay, you lukis alkohol pluskan dengan acid catalyst yang you dapat. If let's say the question gunakan H2SO4, this is how you do it. You separatekan H dengan the rest of the acid catalyst, OSO3H. Kalau you dapat H3PO4 pun sama, you buat H and you separatekan the rest of the OPO3. If I'm not mistaken, H3PO4. Okay, so that's how you do it, because we are going to take this hydrogen, okay, untuk kita gabungkan dengan this OH. Okay, so how are we going to do that? Okay, di sini because this is not an alkene, alkene sahaja yang buat homolytic cleavage, so the rest of the reaction mechanism of your organic compounds after this is all going to be about heterolytic cleavage. Okay, heterolytic cleavage ni kita akan gunakan double headed arrow, and also the product yang you akan dapat ialah cation and also anion. Okay, after dah buat cleavage tu lah. So what happen here is OH ni dia nak ambil this proton daripada acid catalyst. So untuk dia ambil this proton from this acid catalyst, this hydrogen dia akan break the bond between this hydrogen and the rest of the acid catalyst. So how are we going to do that? First thing first, dekat OH ni, dekat this oxygen, okay, dia ada lone pair. Berapa lone pair? Ada 2 lone pair. How do you know it? Because dia ada 2 bonding pair kat sini, satu dengan carbon, satu dengan hydrogen. Therefore, dia ada 2 lone pair. So what will happen here is, okay, from one of this lone pair of this oxygen atom, walaupun tak ada dalam soalan, tapi bila you nak buat reaction mechanism, you need to show the lone pair. Okay, so you kena buat dekat oksigen ni ada lone pair. Sebabnya kita tak bolehlah buat arrow daripada oksigen ke H sahaja, because from the beginning of the arrow, I already told you, the beginning of the arrow must be from the source of electron. Okay, so kena show the source of electron comes from where? Comes from this lone pair of this oxygen, and then dia akan terus yang dekat hujung arrow ni akan tempat yang dia nak attack tu lah, untuk dia nak ambil this hydrogen. Okay, tapi dia tak boleh ambil this hydrogen je, sebab nanti dia akan buat dengan the whole thing, the bond with the whole thing. So dia nak ambil hydrogen je, so this hydrogen dia kena break the bond with the rest of this acid catalyst. So in order to do so, you have to show another arrow daripada this bond. Okay, as usual, the beginning of the arrow must start from the source of electron, sebab dekat bond ni ada source of electrons, and dia akan pergi towards the one yang dia nak break the bond with lah, which is this oxygen. Okay, this oxygen tak perlu pun letak lone pair, because dia nak break the bond. Yang ni lain lah, sebab dia nak ambil. So dari start of the arrow tu must start daripada source of electron, kena show lone pair. Ini tak apa, kalau nak show pun tak ada masalah. Okay, so sekarang ni dia dah rampas lah this hydrogen daripada acid catalyst OSO3H, and since that dia ada buat heterolytic cleavage kat sini, therefore you should know heterolytic cleavage dia akan form cation dan anion as the reaction intermediate. Therefore okay, sekarang ni lone pair ni dah hilang. Kenapa dia dah hilang? Because dia dah form bond bersama this hydrogen of the acid catalyst H2SO4. So dia dah form bond kat sini. So sekarang ni normally oksigen dia hanya boleh ada dua bonding pair dengan dua lone pair. Sekarang ni this oksigen dia dah ada 3 bonding pair. Ada 1 lone pair. Therefore this oksigen dia akan dapat positive sign. And also because dia attack this hydrogen, that's why dia dapat jadi cation, and this oxygen dekat this acid catalyst akan jadi anion because dia receive. Okay, yang ni kan dia receive 2 electrons from this bond, sebab dia nak break the bond kan. Therefore this oxygen dia akan dapat negative sign. Okay, so you have to remember that. So yang produk dia, oksigen ni dia akan dapat positive sign and 1 saja lone pair, and lagi 1 lone pair ni dia dah buat bond bersama hydrogen, so that's why dah tak ada 1 lagi lone pair, ada 1 saja lone pair. And dekat acid catalyst ni, don't forget the negative sign here, because this, bila dia nak break the bond ni, this oksigen dia terima 2 elektron daripada bond ni. Faham tak? Okay, next ialah the step 2 ialah formation of carbocation. Macam mana you nak form carbocation? Okay, bila you nak form carbocation, you tengoklah, yang ni this is a positive sign here. So untuk you form carbocation, you kena get rid of this protonated alcohol. So dekat formation of carbocation ni, what you will do is you will get rid of the protonated alcohol. Okay, protonated alcohol tu apa? Protonated alcohol tu ialah H2O+. Inilah dia protonated alcohol. OH yang ada H. And then the O ni dia ada plus sign. Itulah nama dia protonated alcohol. Sebab pada asalnya dia alkohol, tapi kita protonatekan dia. Itulah protonated alcohol. So kita nak get rid of the protonated alcohol. How? So kita salin balik this structure. Untuk form carbocation, we have to get rid of this. So how? We can do it by breaking the bond between this carbon and also this protonated alcohol. Okay. So again, bond ni yang terlibat, and bila you nak buat arrow tu, make sure the beginning of the arrow has to come from the source of electron. So that's why the beginning of the arrow is specifically needed to be here. Kena draw daripada this bond kepada protonated alcohol. alkohol. Okay, tak boleh daripada carbon, daripada bond. Carbon ni tak ada elektron, yang ada elektron dekat this bond, faham tak? And then kita nak break the bond pun, so that's why it has to be from the bond. You have to be specific about it, because ramai orang yang silap. Dia buat arrow melayang-layang. Tolong ya, kena specific arrow, kena specific bila nak buat reaction mechanism. Next, what will happen? You akan dapatlah the carbocation. Okay, here it is. Dapat this carbon, dapatlah positive sign sebab dia break the bond here. Okay, and then dia dermakan 2 elektron dekat this protonated alcohol. So now your protonated alcohol dia jadilah H2O. Okay, this is protonated alcohol yang dah jadi H2O because dia dah break the bond here. And how about the anion? You salin balik sahaja. Okay, so now kita dah dapat dah carbocation. Okay, what is the class of this carbocation? This is the secondary carbocation. How do you know that? Because this carbocation is surrounded by 2 alkyl groups. This is the first alkyl group. Okay, and then this is the second alkyl group. Alright, so you need to remember that. Okay, so that's why dia adalah secondary carbocation. Kenapa kita pentingkan pasal formation of a stable carbocation here? Because the more stable the carbocation, the better. Okay, how do you know carbocation tu paling stable? Kita tahu kalau let's say dia towards tertiary carbocation, dia lagi stable. So secondary pun dah stable already. Okay, so next, formation of alkene, which is the major product. So how can you form that? Okay, you salin balik the carbocation yang kita dah form from the step 2 previously. So sekarang ni bila nak buat formation of alkene, okay, kita juga akan buat balik. Okay, hasilkan balik the acid catalyst. Alright, kita kena hasilkan balik acid catalyst. So kiranya that's why it will be the reaction dekat step 3 ni, it is between the carbocation that we have formed in step 2 and also the anion acid catalyst OSO3H. Okay, so what will happen here, this acid catalyst, okay, dia akan reclaim, dia akan ambil balik dia punya hydrogen supaya dia dapat jadi balik H2SO4, because catalyst is not used up in the reaction. Okay, so dia hanya akan speed up the reaction, so therefore you have to make sure dia dapat balik hydrogen dia. Macam mana dia nak reclaim dia punya hydrogen? Okay, so dia ambil lah this hydrogen. Kat sini dia tak ada competition, adalah competition. Kalau ambil this hydrogen, dia akan form minor product. Kalau ambil this hydrogen, dia akan form major product. So kita akan ambil hydrogen yang di mana dia akan form major product. Okay, so we are going to take this hydrogen instead of this hydrogen. Okay, so kena ambil hydrogen ni. Jangan ambil hydrogen ni. Kalau you ambil hydrogen ni, you akan form minor product. So you need to take this hydrogen. Okay, so bila kita ambil, sambil kita menyelam ambil hydrogen ni untuk form kembali acid catalyst, sambil tu dia akan form alkene. Macam mana this bond dia akan bawa ni atas macam tu. Okay, lepas daripada bond kepada carbocation ataupun kepada daripada bond kepada this bond. So I'm going to highlight bond yang terlibat in this case ialah this bond and this bond. Okay, you kena ingat ya, arrow ni daripada this bond towards this bond sebab dia nak form alkene, dia naik atas. Okay, therefore you akan dapatlah you punya major product, the stable alkene. Okay, C double bond C, and then ada H, bukan H2 tau, H ni dah hilang dah. H ni dah hilang pergi mana? Pergi kembali kepada acid catalyst untuk form H2SO4. And then CH3, kat sini pun H and also CH3. So this is the reaction mechanism untuk form major product from the previous soalan tadi ya, previous example tadi.